This video accompanies Learning IoT with Python and Raspberry Pi. In this video, you will learn how to write if statements. The final script in this video lecture illustrates how to control a piezo buzzer using an if statement. Hence, you will also need a half breadboard, a piezo buzzer, and 2 female-to-male jumper wires. An if statement is a type of conditional statement used in flow control. If a certain condition is true, then a block of code is executed. Otherwise, the block of code is skipped. An if statement contains a line that contains the if keyword, followed by an expression that returns either true or false, followed by a colon. If the expression returns true, then the block of code that belongs to the if statement is executed. If the expression returns false, then the block of code that belongs to the if statement is skipped. This simplest kind of if statement has a single clause. A clause consists of a clause header and a suite. The first line in the if statement is a clause header, and the code that is indented 4 spaces with respect to the clause header is a suite. It is a syntactic requirement of the Python programming language that a clause header must be followed by a suite, and that the lines of the suite must be indented 4 spaces with respect to the clause header. The first line that is reached that is not indented 4 spaces with respect to the clause header signals the end of the clause, and hence, in this case, the end of the if statement. We'll write an if statement that tests if the variable a has a value true or false. Only if a is true do we wish to print out a is true. Regardless of whether or not a is true, we wish to print out after if statement. We'll assign the variable a the value true. The if statement will be composed of the clause header, if a, followed by a colon, followed by the suite, which is composed of a single line, the print function call that prints out a is true. Because we wish to print out after if statement, regardless of whether a is true or not, this print function call follows the if statement. We'll save this script as if lesson. And then we'll run it. And notice a is true and after if statement are both printed out. Next, we'll assign a the value false. Save the script again and run it. This time, only after if statement is printed out. Often you will wish to compare values, testing if one value is greater than another, if one value is greater than or equal to another, if one value is less than another, if one value is less than or equal to another, and if one value is equal or not equal to another. You can use the is keyword and the phrase is not to test if 2 objects are equal to each other or not. Recall that a Python object has the 3 features: type, value, and identity. The is operator returns true only if the objects the variables reference have the same identity and value. Finally, the in and not in are used for testing membership in, for instance, lists and tuples. We'll defer a discussion of testing for membership to a later video. We'll write a script that prompts the user to enter 2 numbers. Then we'll write an if statement for each of the comparison operators: greater than or equal to, less than or equal to, not equal to, is, and is not. We'll begin with the 2 assignment statements for the 2 numbers. The variable a is assigned the user's response to the prompt for the first number, converted to a float type. The variable b is assigned the user's response to the prompt for the second number, also converted to a float type. The first if statement tests if a is greater than b. Notice that Thani automatically indents the line of code that follows a colon. The second if statement tests if a is greater than or equal to b. The third if statement tests if a is less than b. The fourth if statement tests if a is less than or equal to b. The fifth if statement tests if a is equal to b. The sixth if statement tests if a is not equal to b. The seventh if statement tests if the object assigned to A is the same object assigned to B. The eighth if statement tests if the object assigned to A is not the same object assigned to B. We'll save this script. And run it. We'll enter 6.34 for the first number and 12.98 for the second number. We'll run the script again, this time entering 76.98 for the first number and 76.97 for the second number. We'll run the script a third time, this time entering 7.55 for both the first and second numbers. Notice that the values of A and B are equal. However, the object A does not reference the same object as B. Not only can comparison operators be used in if statements, but method calls and function calls can be used as well. We'll write a script that prompts a user to enter a password and checks if the password contains only numbers and if it contains only alphabetic characters. We'll use the string methods isNumeric and isAlpha, both of which return either true or false. We'll use an input function call to prompt the user to enter a password and assign the user's response to the variable response. In the first if statement, we'll call the isNumeric method on response. If isNumeric returns true, then the message "Your password contains only numeric characters" will be displayed. In the second if statement, we'll call the isAlpha method on response. If isAlpha returns true, then the message "Your password contains only alphabetic characters" will be displayed. And we'll add a final print function call after if statements. Save the code. And run it. We'll enter 383. Your password contains only numeric characters, and after if statements are displayed. Next, we'll enter Dudley for the password. And this time, your password contains only alphabetic characters, and after if statements are displayed. And finally, we'll enter Dudley 7. At this time, only after if statements is displayed. We'll next use an if statement to determine whether to turn a buzzer on or not. The script should prompt the user to enter the number of seconds that the buzzer will buzz. The if statement should check if the number of seconds is greater than 0 and less than 5. If it is, then call the on method on the buzzer object and call the sleep function with the number of seconds passed as the argument. Before we enter the script, we'll hook up the buzzer circuit. You'll need a piezo buzzer, 2 female-to-male jumper wires, and a half breadboard. We'll use a GPIO 17 pin and a ground pin. You can use the pinout command from the terminal to display the GPIO pins. We plug the piezo buzzer into sockets J1 and J8 such that the positive lead is plugged into J1. The piezo buzzer is a polarized device. On this piezo buzzer, there's a plus sign to indicate the positive lead. We'll plug the male end of the red jumper wire into socket F1 and the female end onto GPIO 17 and the male end of the black jumper wire into socket F8 and the female end onto one of the ground pins. We'll first import the sleep function from the time module and the buzzer class from the GPIO 0 module. Because we've connected the piezo buzzer to the GPIO 17 pin, we have to create an instance of the buzzer class with 17 passed as the argument. Next, we'll call the input function to prompt the user to enter the number of seconds and convert the user's response to a float type, which we assign to the variable sec. The if statement is used to check if sec is greater than 0 and less than 5. If it is, then the buzzer will be turned on for the number of seconds entered by the user. After the if statement is executed, the close method is called on buzzer and goodbye is printed out. We'll save the script. We'll run this script and enter 5.1. Because we did not enter a number less than 5, the if suite is not executed, and hence, the on method, the sleep function, and the off method won't be called. Only goodbye will be printed out. Next, we'll enter 1.2 seconds. Because this number is greater than 0 and less than 5, the if suite is executed. Go to www.learningiot.net to find links where you can buy Learning IoT with Python and Raspberry Pi.